Today we have a slightly more complicated topic, but a very important one. That is error handling. So unless your function is absolutely trivial and error-free, it's not going to be always the case that you get a result. There could be outside circumstances that make the function return an error. Typically, if your function depends on user input or depends on something that you get from the network for outside, essentially. It's always a good thing, a good practice to have functions that are not depending on the outside. So functions that are well isolated. We call them deterministic function or pure functions. So for example, if you have a function that takes two numbers and adds them together, then you know that the result value will be only depending on these two parameters. And so with same input values, you will always have the same result. And these type of functions are called pure functions. But unfortunately, that's not always going to be the case. You're going to have functions that, for example, take an input from the network. And so let's go with our typical, our classic example of the getChar function. So getChar return a U8 normally. So assuming it returns a char. This char is better than U8. But sometimes, let's say that the user stops the terminal. Let's say that this is coming from outside. So maybe it's the end, and you're not getting a char, a character. In which case you want to indicate that error condition. So before we had we could do an option. We could say that it's either a char or it's a known. So sometimes it's a char, sometimes something like that. But sometimes it would be known. And so either one or the other. You may also want to actually tell the caller the reason of the error. So option is not good enough in that case, because when you have known, you know that there's no value, but you don't really know why there's no value. If the function only has one reason why there's no value, or you don't care about the reason, so option is a perfectly fine way to express the return value. But if you have you want to know why there's error, result is better suited. So result is pretty much the same as option, except that instead of having one type parameter, the option of t right before, now we have result of t, of course, right? But also the type that indicates the error type or the error. And typically, the error type would be enum, would be a union type, because you have an error. You have different possibilities for the error, and you would not combine all the errors together. You can have one or the other error. So you could say, for example, that it's an end of file error, or it could be invalid try error. I actually don't it depends on the semantic of your function, right? Maybe your getChar only accepts function characters that are in the alphabet, the Latin alphabet from A to Z. So in that case, if it's something else, you want to have invalid char. So to express a function that has this type of semantic, what you will do is to say that the result is a char of or an error. So now what you could have is either OK of a char. So that's sorry, a char would be a single quote, right? If it's not OK and you have error, then you would have error, and then the error type inside. So in that case, it would be error, and then, for example, end of file error. So that's a possible return value. These are two types of return values. So your function works, then you can call it like that. You can call, let's say, let C equal getChar. Right? And now C is the result of stuff. Like option, in cases where you are sure that the return is a value, you can call them wrap. You can say that CC equals C and unwrap. And like the option case, also unwrap. Oh, okay. Something about what's the error here? Let's compare and see what's the error. Error does not implement debug. Okay, so the reason why we have this error is because if unwrap fails, if the type that we have is error, instead of getting a value, we get error, then the standard behavior is to panic, meaning that we abort the program, printing the error. So to print the error, this guy here, the error type, has to implement the debug type, so the debug trait. So we have to derive debug. So the reason why we have this is that result and option have some magic. The magic is that in case unwrap fails, there's a panic, or it's not really magic, it's the implementation of unwrap. But when unwrap fails, the implementation will panic and print the error. So we need this debug. So that's one way to handle the. But this way to handle error, error condition, is not really good in the sense that if really you have an error, your whole program will crash. Well, panic and then typically crash because panic is a pretty bad condition. So instead of doing unwrap, what you can do is actually replace that with a question mark. So the question mark, as we had seen in the case of option, the question mark will also unwrap the value. So the result here is a char. But if there was an error, instead of panicking, it would propagate the error out. It would return that error to the caller. In the case of this function, there's no caller. We are in the main, so it will return it out. And the problem here is that this function main does not accept the return of type result. So it's telling us that the question mark operator can only be used in function that return result or option. Right? So in this case, it's result because our guy is result. And again, there's some magic with main. Main normally takes no return value, but it's allowed to return a result. Right? We can return a result, but it has to be a result of a unit, and then any error type that you want. So in this case, it would be error. Expect result from. Okay, so that's okay, and now we have to do okay because there's no return value for this function otherwise. If we don't return here, okay, then we exit the function domain at the end, and it will return this guy. It will be the equivalent of doing this. And this guy here is not the right type here. Right? So the type does not match. So we have to return OK. And OK takes one parameter and a parameter of this value. So remember that this is a value of type this guy. So this unit type, this is called a unit type, has only one possible value, which is the same. It's a bit interesting that for this particular type, first of all, the type is symbols, it's not characters. So the type is actually this guy, and the type has only one value that is also represented the same way as the type. So besides that, there's nothing particular about that. This is the only thing that is a bit odd about this type. So you can see this works because now if we have a character from getchar, we put it into CC, so we unwrap it. But if the return from getchar was an error, this will return this error out of this function. Right? So you will see this type of code very often because in many cases, or should I even say in most of the cases, what you want to do is propagate the error out. If instead you want to do particular error handling, more specific error handling, what you can also do is match, because after all, result is a simple union type that has two possible values, OK and error. So you can match that. You can match that. So if I want to match that, I need to remove this function here. Match that with so these two cases, OK of some value x. Okay, we'll call it CC as before, and then do something with CC. Right. And you can see that there's an error here because the match is not exhaustive. I match over OK. Rust mandates the exhaustive match, meaning that all the values of C must be falling under one of the categories here. So I also have to handle error. If error is error, I can do something. If I don't want to do anything, if I want to match everything, there's also a pattern that is underscore. Underscore will match everything. So underscore is like the star, the watt chart, the watt card for pattern matching. So if I match with this guy, it's basically matching everything else. And match is the order of the clauses in match is important. It's going to match from first to last. And if there's a match, it will stop and not consider the following matches. So even though this guy here matches OK, it's not going to be considered if OK is already matched. So if I do the opposite, if I do this, then the compiler will tell me that because this watt card appears first, OK is never going to be reachable. As I say, unreachable pattern. So the order is important. And you can also see that the gray thing is because, like before, I'm matching all the cases and throwing away, I'm matching the OK case and throwing away all the rest. So I'm only matching one pattern. And if I match one pattern, the if let is better style. Right? You can do if let OK, C, right? And that's going to be strictly equivalent to this code here. So the compiler recommends me to go for the if let syntax. So that's pretty much it for the first approach to error handling. You define your error, and then you propagate like that. But we're going to talk about that a bit more because error handling is fairly important, and it's rare that your code is going to be written without any interaction with other code. So you are most likely going to use another library, or even if you don't use another library, you will use a standard library which is coming with Rust. And for example, if you use the IO library, if you open a file or you use functions that read write into files, you're going to be using this guy, stdio, right? stdio, and you can see that in stdio, we also have a result and an error type. So that's a pattern that's quite common for libraries to define their own error types, right? So like we did here, we define error types for our functions. They also have functions, so they also have the need to define an error. And the error that they define will be local. I mean, will be defined in their own library. So in order to not mix the error that is defined inside the IO package and your own error, we have errors here. We have a standard error, and we may have our own error. So we start calling my error to make the distinction. And if I do my error, right? So this is my error here, and my error here. Right? So these error is not the same as this error. So now everything is working fine. But what if my function here, right, is using a IO function? Right? So if I say file new and then something, or open the file, and should have a path. Here's the path. So should be something like this. And I import the file package. Oh, so it's not inside IO, it's inside FS. And now you can see it return a result of file, which is pretty much expected since our get char return a result of char. So this guy returns a file, so it should be a result of file. But you can notice that it only has one parameter, whereas our result had two parameters. And the reason why is that this result here that is returning is not the result that we're using before. So there are different scopes if you want. The different result types, as long as they belong to different packages, this is perfectly allowed and actually good practice. And so it's common for packages to have their own results. So the package fs actually return a result from IO, because IO and fs are pretty like they're quite related. So what we have here is that the result type here is as I said, not the result, our result, global standard result, but it's the IO result. If you hover over it, over F, I cannot tell that. Okay, I can tell that by going over open and see that open return IO result. Right, so this guy is not the same. So this IO result is essentially a shortcut for a result, the normal result, but of the first is always the value, the type of the value, and the second is the type of the error. So that would, in this case, it would be IO error. Right, so if I take this guy here and I put it here, we see that there's no error because the type that it's specifying is actually the correct type. And this guy, this error, is the error coming from standard IO, which has a different definition, of course, than my error. Right. So if I do that and then I say, okay, in case of error, let's try to open the file. But if there's an error, then abort it. Right. So I'm tempted to do the question mark as before. Right. And you can see that actually I need to remove this. You can see that if I do that, it's not working as expected. It's nearly working as expected, except that it says could not convert the error to my error, because the error that I have here is my error, and it's not IO error. The question mark implementation will try to do a conversion between the error that is return from this expression. So in this case, it's IO error to the one that is coming from this function, which is my error. But in this particular case, this is failing because these two types, they are not related. There's nothing magical about my error. We just because they have similar names does not make them in any way related. So this is failing. If I want to actually return my error, there has to be a conversion between the standard IO error and my error. So I could do that. I could implement a conversion or between these two by implementing the trait from. Right? So there's a standard trait, and trait is interfaces, and some of these interfaces have some magic added by the compiler, meaning that if they implement a particular name, they have some of these traits are automatically used by the compiler if they are present. So in this case, what I want is the from trait. If I have a from trait that says that I am converting from IO error, right? And my trait is for my error. Right? So this is a syntax for saying that I implemented a conversion from IO error, and this is for my error. So if I implement this, then you can see here that this now is okay, because the compiler would take this implementation, the implementation for this interface, to do the conversion from IO error to my error. Right. So all I have to do now is actually add the implementation. So I'm having to implement this guy. So the only method here is the from, and it needs to take one error and return return something from my error. So I have nothing here suitable, so I will add something like, for example, IO error. And IO error, I can make it like wrap the inner type, right? So IO error would take IO error as a parameter. And basically what I need to do then is to return my error, taking IO error, and inside pass this guy. So this is the conversion, and now everything is okay. And if we want to try this, what I'm going to do is actually, so here I'm trying to open a file that does not exist. And if it doesn't exist, this is going to return an error, right? So in normal case, I'm going to return okay. But I'm expecting this to fail because the file does not exist. So if I go get char, and then I'm wrapping the get char like before using the question mark operator. I expect this to fail and panic. So let's run this. Right, so we have this panic. We have the panic that it prints. So my function here returns the main returns my error. So we know that if we have error that propagates out of main, the standard handling for main would be to print out this error in debugging. So it does so. It says there's an error, and the type is IO error, which is the guy here. And that guy here has inside our error, so it's also printing the guy inside. So now it's this message here is the OS error coming from IO, which says basically the file is not found, no such file or directory, and the error code is 2. So I don't really know what code 2 means. It probably means that the file was not open. So this must be a C error condition. So this should explain how this works. But as you can see, this whole thing is a bit annoying, right? There's a lot of things to write for this. So there are packages that make this process a bit easier. So we're going to talk about 2 possible strategies to do error handling using third-party libraries that will make our life a bit easier than having to define this ourselves and write all these kind of functions ourselves. You can see that these functions are not very interesting. They're mostly error boilerplate, and it would be better if we didn't have to do all of this coding ourselves. And that would be a good introduction to our first dependencies. All right, so the first one is anyhow. So I removed the code that is doing the conversion from my error to from standard IO error to my error. So I have this error back here because of the question mark would raise an error. So what I'm going to do is instead of using my own error type, I'm going to use the a more generic and more general error type that is coming from anyhow. So first I have to add anyhow as dependency. So 1066 is the latest version, but I'm not that specific. I can use anything that is 10. And instead of using my error here, I want to use anyhow error. So I could use this way, anyhow result. Anyhow error. But easier way is to actually use anyhow result. Anyhow result will also place the error type, set the error type as anyhow error. So this is strictly equivalent. So I can do this here, and then I can do the same thing here, and remove my error. So essentially, I don't really use my own error type anymore, and I can remove that guy. And you can see that the benefit of using anyhow error is that even though the error type that is sent from file open is of type IO result IO error, this guy can be converted to an anyhow error. Right? So I don't have the problem I had before with my own error. And this allows you to not care too much about what kind of error you're propagating, because now you have this anyhow result that can basically wrap all the errors that are coming from the standard library or from dependent libraries, as long as these errors implement the trait in the trait std error. So there's a trait here, right, that they expect your error to implement, and that's the case for all the errors from the standard library, and I would say for most of the errors from third-party libraries. Of course, I cannot be sure for all the errors from the standard libraries because from the third-party libraries because there's just too many of them. But as long as this condition is met and the condition to implement error is not very high, you just have to have the implementation for display and for debug. So these are for printing out the error message. And as long as your error object has this straight error, then you're good to go. So actually, if we were to do this with our error type, we could have, okay, so it was EOF error, right? So as it is now, this is not working. So if I have something that is of type result my error, so I'm going to explicitly put it. I'm going to put it something like that, and that is something that technically is of the right type. Right, so it's a standard result, but it doesn't know standard result of what. So let me put it this way. Right. The problem before was that by assigning this type like that, the compiler could not infer the type of the good side, the proper side. So I help it by saying that it's actually a result of type unit and of type myError. The side myError could correctly be deduced because of this type here. All right, so if I have that and I do a question mark, so I use the A operator, you can see there's error because myError is not implemented this straight, which I can do. I can do implementation standard error for myError. And then I have to actually do the implementation. But to do the implementation, I actually have to implement debug and display. These are the two only things that is required. Right, so I let the compiler generate some, let the IDE generate some boilerplate. I'm not actually interested in implementing these functions because I just want to demonstrate the syntax. Now you can see now there's no error, right? There's anyhow could take my error type because it has this conversion. As long as you make all your return type of being anyhow result, you don't really have to care explicitly about the type that you have here. The second library we want to look at today is this error. So here is so anyhow it's this error. I move this one, this error, and likewise let's give a version number this way. Don't really have to, because if you don't do that, it's the same. But it's a bit more clear, I would say. And this error is more suited for libraries. Okay, so anyhow doesn't exist anymore, so I have to remove this. Actually, both libraries can be used together. But anyway, let's remove. Let's use a standard result for this one, and then implement myError like before. Okay, so that would be myError here. And we are back to having an error because standard IO error is not convertible to myError. So before we implemented myError like this in myError, and let's just put IO file. The issue was that we have to implement my debug time, so we have to derive debug. So the issue was that we have a question mark and then it's not valid because stdio error is not convertible to myError, and before we implemented the conversion ourselves. With this error is a library that allows you to define your own error types, but with less boilerplate. So what you can do is import this error and derive error. So again, if you remember, deriving something brings the a code generator that is implemented in this library. So this error, this guy here, is basically producing a code generation for the entire the structure that follows the derive. So for debug, it was generating the debug trait. For error, it would generate a boilerplate for my error. And what it expects you to do is to have the error messages that will be displayed when we get these errors. So what I need to do is to say that error has this error message, for example, and of file and reach, something like that, whatever. So now you see that error is gone, but we still have this. We still don't have a conversion from a standard I/O. So what you can do is to say that we are going to wrap the I/O error like before, right? We're wrapping my I/O error, and we're wrapping I/O error like that. So again, something is missing, but this time I'm going to say that we're implemented by wrapping this guy here. So and you indicate that this is a wrapper of I/O error by saying that this guy is an error transparent. So we want the inner error to be transparently propagated through and wrapped by this guy here, and it's coming from this guy here. So you do this, and this dependency will generate the code that we had to write manually before, and now this is working. So this way, you can have your own library, implement your own myError that you're gonna export it, and it's gonna have the your own errors defined like this here. You can also have parameters if needed, and you can also add if your error has a parameter, let's suppose it has a parameter string. Your error string here, so that it's displayed when we print out the error, can be also taken as a parameter here, like. So remember that and now our class myError also implements the trait std error. So now this guy works, we work also in anyhow. So if I put back the anyhow crate, and we can see that let's say main return anyhow. So we don't have that. So we have just anyhow results. We get the get char here. So it's a result which is my error, but I can still use the question mark because question mark works with anything that implements a standard error, which is the case for my error. So you have a lot of stuff that is generated automatically for you if you use this error crate error. So typically, again, when we use this error for libraries because you can have specific errors, and then if you have an application and you don't really care too much about like being precise about what error, you can use anyhow. So in this today, we saw a couple of good things. We saw error handling. We saw also a little bit about traits because we are introducing the error trait display and debug. We use that. We also started using third-party libraries. So we used this error in anyhow. We extend a little bit about how we the derived magic, which is like micro code generation. We also talked about this special operator, the question mark, that is also special. Question mark. We also talk about implicit conversions. Was not exactly implicit conversions because the code generated by this guy has a call to the conversion operator but it's hidden by the compiler. The question mark is a fairly powerful operator. Then what else did we talk about? We also talk about distinction between libraries and application code. So we covered a lot of topics today. Hopefully, this is a good example of how many topics that we talked about earlier tie together in a concrete example.